In this video, we're going to start the KutaSoftware free worksheet using trigonometry to find lengths, and that's under the Infinite Algebra 1 tab. I'm going to split this up into two videos doing numbers 1 through 9 in this first video, and then finishing out with 10 through 18 in the second. So our directions are to find the missing side and round to the nearest tenth. Go ahead and write SOHCAHTOA at the top of your page. Remember, if we're working with the sine of an angle, we're using the opposite length over the hypotenuse side length. If we're working with cosine, we're using the adjacent side length over the hypotenuse. And if we're using tangent, we're doing the opposite side length over the adjacent side length. So in number 1, we have to find the measure of this side x. We're given an angle of 27 degrees. We can go ahead and use this angle of 27 degrees, knowing that x is opposite that angle and 10 is adjacent to that angle. So we have opposite and adjacent, so we're going to do tangent. So the tangent of 27 degrees equals opposite, which is x, over the adjacent of 10. Now remember, we're solving for this x. We want to find out what that length is, or what that measure is. So in order to isolate that, we're going to multiply both sides by 10. Now we have 10 times the tangent of 27 degrees is equal to x. So then we just have to type in our calculator 10 times the tangent of 27, making sure our calculator is in degree mode since we're working with degrees. And that's going to give us 5.095. So rounding that to the nearest tenth will be 5.1. So 5.1 is equal to x for number 1. So the length of this side is 5.1. And number 2, again, we're solving for this side length x. We can use the angle measure of 25 degrees, knowing that x is opposite that angle and 10 is adjacent to that angle. So we're going to use tangent again and do the tangent of 25 degrees equals the opposite, which is x, over the adjacent of 10. Now, same as before, we need to isolate this x. So we're going to multiply both sides by 10, since whatever we do to the right, we do to the left and vice versa. So 10 times the tangent of 25 degrees is going to be equal to x. 10 times the tangent of 25 equals 4.66, which rounds to 4.7. So x is equal to 4.7. In number 3, we're solving for x again. However, this time, x is the adjacent side, and we're also given the hypotenuse. Remembering SOHCAHTOA, we're going to be using cosine because we're given adjacent a and hypotenuse h. Go back up, SOHCAHTOA, here's our adjacent and our hypotenuse, so we're going to use cosine. So the cosine of 39 degrees is equal to the adjacent x over the hypotenuse 7. Just like before, we're isolating this x so we know what that's equal to. We'll do that by multiplying by 7 over 1, which is simply 7. We'll be left with 7 times the cosine of 39 degrees. That entire quantity is equal to our side x. So go ahead and type into your calculator 7 times the cosine of 39 degrees, and you'll get 5.44, which rounds to 5.4. So 5.4 is x. In number 4, x this time is our hypotenuse, and we have 8 that's opposite our angle. So we're using the opposite and the hypotenuse. So remembering SOHCAHTOA, we're going to be using sine. So the sine of 46 degrees is equivalent to our opposite, which is 8, over our hypotenuse of x. We still need to isolate this x, but this time our x is in the denominator. So we need to start by multiplying both sides by x over 1. When we do that, we'll get that x times the sine of 46 degrees equals 8. But we're still isolating this x, so now we're just dividing by the sine of 46. And whatever we do to the left, remember, we do to the right. So x is going to be equal to 8 over the sine of 46. 8 divided by the sine of 46 degrees will give us 11.12, which rounds to 11.1 for number 4. In number 5, we're solving for x given this angle of 23 degrees. We know that x is opposite 23 degrees, and we know that 6 is adjacent to 23 degrees. So, remembering SOHCAHTOA, we're going to use tangent. So the tangent of 23 degrees is equal to the opposite, which is x, over the adjacent, which is 6. Remember, we're isolating this x to find what that side is equivalent to, so we're going to multiply both sides by 6 over 1, which is the same as multiplying by the whole number 6. So we have 6 times the tangent of 23 degrees, and that's equal to x. So we have 6 times the tangent of 23 equal to 2.54, which rounds to 2.5 for number 5. In number 6, using the given angle, 46 degrees, we have our adjacent, which is x, and our opposite of 7. So we're using tangent for this as well. The tangent of 46 degrees is equal to opposite 7 over the adjacent x. Now you remember, x is in the denominator, so we're going to have to do more than one step like we did in number 4. Start by multiplying by x over 1. That'll leave us with x times the tangent of 46 equal to 7. When we get that, all we need to do to get this x by itself now is to divide by the tangent of 46. That'll give us x on the left, and that's equal to 7 over the tangent of 46 degrees. When we enter that into our calculator, 7 divided by the tangent of 46 degrees, we're going to get 6.75, which rounds to 6.8. So the answer to number 6 is 6.8. In number 7, we're going to use the angle measure of 72. X is opposite that, and 20 is adjacent, so it's going to be tangent again. So the tangent of 72 degrees equals opposite x over adjacent, which is 20. In order to isolate this x, we're going to multiply both sides by 20. So we'll have 20 times the tangent of 72 degrees equal to x, since we're left with x on the right once 20 cancels out. Entering that in, 20 times the tangent of 72 is equivalent to 61.55, which rounds to 61.6. So x is equal to 61.6, or 61 6/10. Number 8, we're solving for x using this angle of 54 degrees. We know that x is adjacent to 54, and we know that 12 is the hypotenuse, because the hypotenuse is always directly opposite the right angle, or in other words, 90 degrees. So we have adjacent and hypotenuse, that's A and H, so in SOHCAHTOA, we're going to use cosine. the cosine of 54 degrees equals adjacent x over hypotenuse of 12. In order to isolate that x, we're multiplying both sides by 12 over 1. So we have that x is equal to 12 times the cosine of 54 degrees. When we enter that into the calculator, we get that x is equal to 7.05, which rounds to 7.1. And a quick note, logically, 7.1 makes sense because you know your hypotenuse is always the greatest side length, and 12 is indeed greater than 7.1. And lastly, in this video, we'll go over number 9. Number 9, we're solving again for this side length x, given the angle of 40 degrees. X is directly opposite 40 degrees, and we're also using the hypotenuse. That's going to be SOH, S-O-H. So we're using sine, opposite, and a hypotenuse. So the sine of our angle of 40 degrees is equal to the opposite, x, over the hypotenuse of 19. In order to isolate the x, we're multiplying by 19 over 1, which is simply 19. So 19 times the sine of 40 degrees is equal to x. All we have to do is enter that into our calculator. 19 times the sine of 40 degrees equals 12.21, which rounds to 12.2 for number 9. And as always, go ahead, click the like button, and subscribe to my channel, and don't forget to comment if you have any questions below. Continue on to the next video where we'll finish out this worksheet doing numbers 10 through 18. In this video, we're going to finish the Using Trigonometry to Find Lengths free worksheet on KutaSoftware under the Infinite Algebra 1 tab. We're going to do numbers 10 through 18. If you're still getting familiar with when to use sine, cosine, and tangent, at the top of your page, feel free to write SO, CA, TOA. This is a little acronym to help you remember when to use sine, cosine, and tangent. Sine is used when you're given the opposite and the hypotenuse. Cosine is used when you're given the adjacent side and the hypotenuse. And tangent is used when you're given the opposite side and the adjacent side. So we're solving for x, given this angle of 31 degrees. In this case, our x is going to be our opposite, and our 10 is our adjacent side. And since we have the opposite and adjacent, we're going to be using tangent. The tangent of the measure of the angle, which is 31 degrees, is equal to the opposite side, x, over the adjacent side, 10. We're isolating this x to figure out what it's equivalent to, so we're going to multiply by 10 over 1, which is the whole number 10. So we have that 10 times the tangent of 31 degrees equals x. Type that into your calculator, making sure your calculator is in degree mode. We're doing 10 times the tangent of 31, and that's equal to 6.00, but we're rounding to the nearest tenth, so that's going to be 6.0. So x is equal to 6.0 for number 10. And number 11, we're given this angle of 38 degrees. We have the opposite side of 20, and we have the adjacent side of x. Opposite and adjacent. Again, we're using tangent. The tangent of 38 degrees is equal to the opposite of 20 over the adjacent of x. We need to isolate this x, but we need to get this x out of the denominator in order to isolate it. So we're going to start by multiplying by x over 1, which is equivalent to x. So we have x times the tangent of 38 degrees equal to 20 over 1, which is 20. Now to get x by itself, in this case, we're going to just divide by the tangent of 38 degrees. When we divide by the tangent, we're doing 20 divided by the tangent of 38 degrees, and that's going to give us 25.59, which rounds to 25.6 for number 11. In number 12, our angle measure is 74 degrees, and we're using the adjacent of 19, and we're using the hypotenuse, since the hypotenuse is always opposite the right angle, and that is our x. So having A and H, going back to where we wrote SOHCAHTOA, A and H is going to be cosine. So we're doing the cosine of the angle measure, which is 74 degrees, and that's equal to adjacent 19 over hypotenuse x. Again, the x is in the denominator, so we need to get it out of there, and we're doing that by multiplying by x over 1, which is simply x. We'll have x times the cosine of 74 degrees on the left-hand side. The x's cancel out on the right to give us 19 over 1, which is 19. Then, to isolate the x, we divide by the cosine of 74. When we do that, we're left with x on the left, and then entering that into the calculator, 19 divided by the cosine of 74 degrees gives us 68.9 as our answer in number 12. For number 13, the angle we're using is this 16 degrees. X is opposite that angle, and we also have opposite the right angle, which is the 90-degree angle, and that's 18. So we're using opposite, and we're using hypotenuse. We know this to be sine. So, sine equals opposite over hypotenuse. So the sine of that 16 degrees equals opposite x over the hypotenuse 18. Multiplying both sides by 18 over 1 will give us that 18 times the sine of 16 degrees equals x. And entering that into the calculator, 18 times the sine of 16 will give us 4.96, which rounds to 5.0. Number 14, we're going to use this angle of 40 degrees. X is opposite that angle, and 20 is the hypotenuse. So again, we're using sine. The sine of 40 degrees equals opposite x over the hypotenuse of 20. Multiply both sides by 20, and that will give us that 20 times the sine of 40 degrees equals x over 1, which is x. So 20 times the sine of 40 degrees, entering that in on the calculator, will give us 12.85, which rounds to 12.9. So 12.9 is equal to x. Number 15, x is opposite the angle, and we have the hypotenuse of 34. So again, we're using sine. Sine of 22 degrees equals the opposite side, x, over the hypotenuse of 34. Multiply both sides by 34 over 1 to get that 34 times the sine of 22 degrees equals x. Entering that into the calculator, 34 times the sine of 22 equals 12.73, which rounds to 12.7. In number 16, we have our hypotenuse of 22, and x is opposite. So opposite and hypotenuse, O and H, we're using sine again. So the sine of 43 degrees equals the opposite x over the hypotenuse of 22. Multiply by 22 over 1 to get that 22 times the sine of 43 degrees equals x over 1, which is x. 22 times the sine of 43 degrees gives us 15.00, which is 15.0 for number 19. Number 17, we're using this angle of 63 degrees. X is our hypotenuse, and 23 is the adjacent side. So KutaSoftware CAH has adjacent and hypotenuse, so we're using cosine. The cosine of 63 degrees equals adjacent of 23 all over the hypotenuse of x. This x is in the denominator, and we need to get it out of the denominator. We're doing that by multiplying by x over 1. So we'll have x times the cosine of 63 degrees equal to 23. Then all we have to do is divide by the cosine of 63 degrees. Since the cosine of 63 divided by the cosine of 63 is 1, so we'll have x left on the left side. Whatever we do to the left, we do to the right. So again, we have to divide by the cosine of 63 degrees. 23 divided by the cosine of 63 will give us 50.66, which rounds to 50.7. So 50 and 7/10 is our answer for number 17. And on to our last problem, number 18. But before I work through this problem, please give me a thumbs up and go ahead and subscribe to my channel. In this case, x is our hypotenuse, and 37 is opposite the 37 degrees. So opposite and hypotenuse, we know we're using sine. The sine of 37 degrees is equal to opposite of 37 over the hypotenuse of x. We need to get the x out of the denominator, so multiply both sides by x over 1. So we have x times the sine of 37 degrees equals 37 over 1, which is 37. Divide both sides by the sine of 37 degrees to get that x is equal to 37 divided by the sine of 37 degrees, 61.48, which rounds to 61.5. So 61 and 5/10 is the answer to number 18. And that wraps up the video on using trigonometry to find lengths.